So what we're going to talk about today is wave interference. You don't have to write this down. I just want you to think about something. So how do waves interact with each other? So let's just start with, say, wave 1. And wave 2. Let's say they're identical. What if they crash into each other? What happens? Take out a piece of paper and write down what you think happens when these two waves collide. What is interference then? Do the waves get bigger? Does it get smaller? Does it? Write that down.
Can I just say it?
Sure.
Yeah, well, you write that down.
Hey, Joseph. You have any paper? Thanks, Jason. Show us some good balls.
Okay, you should have something written down. You could just draw something of what you think is going to happen, of how they interact together. What would happen if they collide?
You gotta show her that exactly.
I have a feeling that everyone will be ingredients.
See, that makes so much more sense because
Oh, that's great.
Everyone gets here.
yeah, that's always one mark.
Okay. I'm going to get some of you to read yours out. Okay. Addison, can you read yours? They create the same size wave. Okay, interesting. Can you say yours?
They stop or break apart into chunks of waves.
Okay, Aiden, can you say what you said? No, tell me exactly what you said a minute ago.
Should wrote it down.
They come together to make double the size because they're the same thing. Okay.
It's not exactly what I said. Along those lines.
Well, yeah. Okay, read that one. Read yours.
Think that they'll bounce off each other, go in opposite direction.
Okay.
Arrows. Fine, Rob.
Who said something about canceling?
Oh, I said.
Can you read yours?
I said I think that the frequencies will collide and cancel each other out now in motion.
Their frequencies will collide and they'll it'll cancel out. Okay. Aiden and Rachel and sort of Reed are right.
Yes, I am.
But how can they all be right? Aiden said it will double. Rachel said they'll cancel out, and Reed said they'll kind of bounce back. Probably depending on the frequency. What if both of these waves are the exact same frequency? How can they all be right? Hmm?
If it's the same frequency, it won't be.
Okay,
All right.
but I said they're all right.
It actually reads sort of right.
Yeah, I'm going to focus more on Rachel and Aiden's answers. Aiden said they'll double, Rachel said they'll cancel out. How can both be right if I'm using the exact same waves? Matt?
It'll make a new frequency.
Make a new frequency,
So
okay.
it'd be double the two, but it'd still cancel out the other ones.
Maybe. How are these waves? Okay, let me give you a hint. How are these waves interacting? How would I make a double wave?
Well, if they lined up at the same time, like if the one waves were going like this and the other one was coming and it was going the exact same, the met up, then it'd be no.
Okay, good. Let me use a different color, let's say. So let's say this one is blue. Say they're the exact same. I know that's not perfect, but. So Dylan said if they meet up exactly at the, so that the troughs and the crests are the exact same spot, so that they overlap each other. Aiden's right. They will double and produce a new frequency, as was suggested before.
Same.
Okay? So that's what will happen if they both meet up with the troughs and the crests at the exact same spots. So when those waves collide and they make a bigger wave. So has anyone gone tubing before? And they spin donuts to make a lot of waves. So when they're spinning donuts around and around, it depends which wave you hit, right? Because some of those waves are really small or basically nothing, but sometimes, especially if you get a double donut, those waves, if they collide correctly, they'll actually double in size, right? That's why double donuts are so awesome, because those waves have collided and doubled in size. Put it away, please.
Unless you're looking at double donut.
Yeah. And so the waves are actually twice as big. That's why that happens, is because those waves collide perfectly. But you need a good driver to make sure that they're doing the waves correctly and that they're swinging around your tube perfectly at the right angles so they go up. One time when I was a kid, we had a bungee cord on our tube till they became illegal. But it was fun anyways. It hurt though.
Breaking the law.
Okay. Until it became illegal. Okay, so that's one way that waves can interact and actually double in size. This is called constructive interference, because this is interference of waves, but we've actually constructed something bigger. So this is constructive interference. So you could write that down on your sheet. If the waves collide in this way, so this is like blue or black is wave 1. You could use a dotted line or something if you want, or if you have different colors. And then blue is wave 2, and then the red is the resultant wave. This is called constructive interference. Okay, good? Huh? Remember this? Copper and silver nitrate? Make silver and copper nitrate? Single replacement? You guys? Going into Chem 20? It's going to be good. It's weird because the grade 12s have done Chem 20 and 30, so it's like, I don't know.
It's like they're not even grade 12.
I know. It's like they're university students or